effective engineering design in terms of fabrication, logistics and erection, as well as structural performance is convincing. The results of detailing and optimization, short construction time and reduction of employed material are remarkable. The durability with modern hot dip galvanizing, options of reusability, modular systems, universal application and affordability are the perfect agenda of an engineered sustainable steel construction. Congratulations!
So, and now you want to know, congratulations to whom? The owner, of course today not here, is the Ministry of Transport and Communications of Peru. So, but now we come to the core architect, engineer and general contractor is Beard of Portugal. So, yes please. And the steelwork contractor is Mühendislik İnşaat Çelik. Yes, please. Here in the middle and you get. See, don't be shy. You are the star today. Yes. So having a good photo is very important.
Look at the camera.
And now you explain us a little bit about the bridge. You need a microphone, maybe you put it over there. Or...
Good afternoon. First of all, I'd like to greet all the presents, and particularly the members of ECCS and the jury of this 2022 European Steel Bridge Awards. For us in Berg, innovation only makes sense when it can be translated into effective value for our customers and for the society in general. This highly prestigious award is very important to us as it reveals, validates and prizes the outcomes of the projects that took place in 2019 in Peru, where Berg designed and supplied 148 modular bridges. Berg is a company that started in 2006 and have been developing its activity mainly in equipment for bridge construction. But around 2017, we started a new department, the Modular Bridge Solutions Department, so-called MBS. And in the last days of 2018, we were awarded with a contract of 125 bridges and then an addendum of extra 23 bridges for the Peruvian Ministry of Transport and Communications. This project had Berg as the contractor and structural engineering firm, and the Turkish company MİM Mühendislik as the main steel fabricator. After the natural hazard of El Niño Costero in 2017, the Peruvian government requested these 148 bridges to replace damaged structures across the country. And during 2018, the MBS department had been developing an optimized solution that fulfilled all requirements of the tender. All this staggering number of bridges should be totally metallic, have variable spans between 16.8 and 61.6, should be single lane, should be designed according to the American standard AASHTO, and all components are to be hot dip galvanized. Besides galvanization, deck model's surface should be protected with an anti-skid coating. In order to optimize steel weight and increase the chances of tender award, BERT created two bridge models designated MB36 and MB60, respectively for spans up to 36 and 60 meters approximately. Both models are half-through type, constituted by longitudinal trusses with transoms and metallic decks supported between them. Here you can see a bridge section, and here the transversal section. The quality requirements of standards EN 1090 were completely followed in all fabrication processes, and the quality process was audited and certified by an internationally accredited third party. The fabrication of the 7,000 tons of steel started in January 2019 in the fabrication plant, fully optimized for this project in terms of man labor and equipment, reaching a production peak of 550 tons per week. Transport and logistics optimization, not only in terms of costs but also time, was also a great challenge in this project, as the total amount of containers ascended to 379. The installation of the first bridges in Peru were supervised by BERT. The most common process is launching, which means that bridges are assembled in one of the margins and are launched to the other. For this is necessary a launching kit constituted mainly by a nose and rollers also supplied. I now invite you to watch a video of this installation, so please. This was the device to cross the river before the bridge. Thank you. I'm not really finished. I have some more issues. Well, as a summary, I'd like to focus on 3 or 4 very important points, very quickly, I promise. The first one is sustainability. Well, this is my presentation again. Thank you. Okay. As I was saying, the first one is sustainability. At Baird, we pride ourselves on building durable and reusable structures, minimizing negative impacts on the environment. In this project, our lightweight modular bridges generated approximately 550 tons of steel savings, which is around 7% of the project, which is also reflected in the transportation of less 21 standard 40-feet containers, comparing with similar solutions of our direct competition, which is Bailey bridges. These facts, combined with the optimization of the load inside a container, leads to significant reduction of CO2 emissions during logistical process. We aim to leave the lightest possible footprint by minimizing material consumption, waste, CO2 emissions, and embodied energy during fabrication and construction, and ensuring that all components are reusable. Bridges' life cycle is quite extended thanks to galvanization, which allows minimized maintenance efforts. Our prefabricated bridges also lead to reduced quantities of concrete, reinforcement and excavation volumes in foundations, by being lighter than other alternatives. Also, the means used for installation are very basic, reducing financial and environmental impacts. The second point is optimization. Baird develops optimized, clean, aesthetical, economical solutions that can be offered at low prices. This means that the client receives high-quality metallic structure adapted to local requirements with optimized weight and low maintenance. And all these characteristics enable us to say that governments and populations around the world are being protected and well served. In the end, they can buy more bridges with the same amount of public money and get bridges that, by their characteristics of quality and maintenance, can be considered more permanent and not provisional. The third point is related with the modular bridge market. Nowadays, modular bridge market is dominated by the concept of Bailey bridges that were invented during the Second World War by a British gentleman. He brilliantly developed a solution to promptly substitute damaged bridges with new ones prepared for heavy tanks that could be assembled in few days with man labor only and no special equipment. This concept is still used today and clients are totally familiarized with it, many times constructing their tender specifications in a totally rigid way that no other solution is accepted. But the bridges in this project has demonstrated that other concepts are more effective for the conditions that exist today. This project was a step to the void for our clients that trusted us and had the courage to accept a change in the paradigm of modular bridges. Despite all the initial distrust and suspicion, the client feedback was great, and as well as installers and populations. Having said that, we think that it is important to base the specifications in bridge performance and not in bridge concepts. By doing this, public and private clients will be putting the optimization in the hands of engineers and enabling the technological progress, getting a product more adapted to their reality. And finally, a word to say that modular bridges really make the difference in people's lives. These kind of bridges are many times bought by governments, by dozens, to act locally in small villages, not only in emergency situations, but also to solve limitations that persist for endless numbers of years. These bridges permit populations to have access to hospitals, to schools, and enables the dynamization of local economy, establishing new routes for goods outflow, having a tremendous impact. The first photo here is the device used to cross the river before the bridge, and the second photo is from the inauguration of one of the bridges in Peru, near Cusco. And it's obvious the joy of people to have a new bridge. This same feeling occurs in many other locations where a Baird bridge is installed. And to finish my presentation, I'd like to acknowledge firstly to our client, Provias Descentralizado from Peru, and to our main steel fabrication, MIM Moindislik, here represented by Mr. Hamed Suyun. One final word to dedicate this prize to two great leaders. José Pedro Matos Fernandes, that was the director of Modular Bridges Department and project director. And also dedicated to Hugo Coelho, the production director of BERT. And once again, thanks to ECCS, thank you all.
Thank you very much. I think the beauty of those bridges are in the technology, or in other words, engineered sustainability. Thank you.
Thank you.
So we come to the first main category, namely the cycle and pedestrian bridges. The award goes to the De Lille Langebro Bridge in Copenhagen. The movable bridge across Copenhagen Harbor is a slender and elegant masterpiece of structural and also mechanical engineering design, and a very sophisticated structural steelwork. At midspan, the hydraulically moved mechanical moment-stiff connection enables a slender structure and a fine impression of lightness over the waters. De Lille Langebro, a complex structure of high precision, demonstrates the means of structural steel in an adorable way. This is the praising words the jury found for the winning project in the category cycle and pedestrian bridges. The owner is Reldania Bay and Big from Copenhagen. The architects, well-known Wilkinson are from London. There is a joint venture of 3 Dutch companies, Baukombinatio Mobilis, TBI and Hollandia Infra. And today here, and welcome the steelwork contractor Hollandia Infra. So where is get the first diploma. Congratulations. And you get. And I want you now to hold the award.
Yes, thank you very much. Good afternoon, everybody. Yeah, we are very proud to award this award today. And as already mentioned, we have not done it with ourselves. We have done it with a big team, with our partner TBI Mobilis for the civils and Hollandia for the steelwork. It is difficult to go in 10 minutes to our organization and to such a project. I will go very fast to some slides of my organization, and then I will show you some pictures of the bridge. And also that has to be done very quickly because I have only 10 minutes. So Hollandia is a family-owned organization working in Northwestern Europe. Sorry. Green one. We do the whole scope from design to fabrication and installation, maintenance, erection, everything is part of our scope. We have established in Krimpen aan den IJssel, just near Rotterdam, with an open entrance to the North Sea. Safety is very important at our organization. We invest a lot in safety. We do projects in Northwestern Europe, and we would like to work cooperative with our partners, not just as a subcontractor, but as a partner, bringing the best to the project. Here you see in various of projects we have done in the Netherlands, but also abroad. Bridge in Oslo, bridge in Sweden, full design by ourselves. So refurbishment bridge in the Netherlands, movable bridge in the Netherlands as well. This is also an award-winning project in the Mackin Street Bridge, the Samuel Beckett Bridge in Dublin some years ago. The Maaslandkering. We do also a lot in barriers, flood barriers to keep our land dry. As you know, the Netherlands are at least 6 meters below sea level, so this is very important for us to keep our feet dry. So all the projects, all to do with water management. And we do it in the UK as well. In the UK have also to deal with rising water. This is in Ipswich. We've done a project in Boston as well. This is the big sea lock in IJmuiden. So a number of projects we are working on. This is the Boston Barrier, also full design by our engineers. I go very quickly to the presentation. This is in Belgium, just near Belgium, the lock H by Terneuzen. And this is the famous the I-360 tower in Brighton, the south of England. This is also a nice example. Normally this is in concrete. This is a steel tower from weathering steel, which is a presentation with something presented today as well. And this is fully fabricated in our yard and brought to site and built up in 2 days. And of course the famous London Eye, as well known by a lot of you. Then I come to the Lille Langebro. This is a very, very complex bridge, the most complex bridge we've ever built. And when we start with this bridge, I asked the architect a favor, because he made the decision to make the bridge as slender as it is now, to have a moment connection in the middle. And we have a lot of engineers here. You all know that if you have a movable bridge and in the middle, a moment connection, that requires a lot of hydraulics and a lot of engineering. And I asked him, could you take that away, because this is a kind of making a watch on a bridge. That was not possible, because he would like to have the slender visibility of the bridge. So that took us a lot of engineering, and I will come back on that later. So this is the client, Wildenia, joint venture between Mobilus and Hollandia, 2 Dutch companies, and we use CIG as the steel supplier to bend the steel in the right shape. And SH Group is a Denmark company for the hydraulics. It was also a project with early contractor involvement, so we have a lot of discussions with the client before we award a contract. And one of the nice things to awarding this contract was that just at the end of that process, we need to build a piece of the bridge in a scale of 1:1, exactly conform the drawings, and we have to bring it on site together with the only competitor that was left. So there were 2 pieces of bridge on the site, and then the architect and the owner comes and has an inspection of how it looks like, and it was a number of percentages for awarding the contract. So it was very nice, but we said also to our team, if you make it too nice and too smooth, we have problems during production, because he said, looks is not the same like the model you did. But that was very nice to experience with. The architect is a very important role. We were very close together, because the machinery which is in the middle of the bridge was not space enough, so we did a lot of re-engineering, value engineering to make it fit for purpose, and therefore we need good cooperation with the architect and the engineers. So 2 fixed spans of 40 meters and 2 movable parts. We can see how we build the coffer dams by our colleagues from Mobilus in the center of the river. too quick. So you can see here some of our production, and each and every piece of steel was in a curve. There's not in a single piece of steel which is straight, which was very difficult but also nice to work. This is the center pylon in which the drive system is located. You can see 4 pinions which drive the bridge. You can see here a photograph about it. And you can see here, is that something to? No. In the middle, this is the center connection, which is a hydraulic cylinder which pull and push the bridge to create a moment in the center of the bridge, and then you can make the bridge some more slender than without that mechanism. But it requires a very high amount of accuracy and very narrow tolerances to make that working. And because the bridge is slender, it also drops down a little bit when it is open and it is moving, and so we have to make also a very special guide system at the end of the bridge to lift it up again and to bring it exactly in its correct position. This is shown here, and this is all contractor design, because that wasn't at that much level designed by the architect and the engineers. I think this shows a little bit in our 3D model how it works. So we put the whole bridge in a BIM model to see where we have clashes, and it brought us a lot of discussions, or it avoided a lot of discussions afterwards. So you can here see these are the flaps between the 2 bridges, which also is very complex, that it fits and that it goes smooth to the bridge itself. So that causes an enormous amount of engineering to make this fit for purpose. And that is not what you see if you see the bridge when it's closed, but it all happens when you move the bridge. Here exactly the same. Sorry. You see here a noise wheel in the front, which goes to a guide, which lifts the bridge a little bit, and so that you come to the next step. It takes too much time to go to the whole video, but it gives you an impression. So you can see here in the structure what is designed. Hydraulic cylinders, one above and one below, which gives the bridge the moment connection in the middle, to give them the slenderness what was required. So what I already said, this is a kind of watch design in a bridge type. You can see here on the side of it a torpedo that wasn't there because the hydraulic cylinders and the equipment was designed too small, and to get it fit for purpose, we made there a kind of a torpedo on the side of the bridge so that the whole machinery can be installed. You can see how it open again. So this is a kind of a machinery system to close the last gap when you have a lot of flaps. So when the bridge goes close, then the last flap needs to be uplifted. And also therefore we need a very special movable block to keep also the last piece of the bridge closed, because in a pedestrian bridge and a bicycle bridge we need to be very careful that people are not injured when they pass the bridge, of course. You can see that piece of steel when it was underneath the bridge, and you could imagine that it was never foreseen during the start of the project that such equipment was needed to make it 100% functional. This is just a video when we close the bridge. And you could imagine that you have 4 bridges, you build every bridge by itself, but if you put the bridges along each other, then you need a perfect curve along the 4 bridges. And if you look the photos or you visit Copenhagen, you see that the curve is perfectly go through the 4 pieces, which was an incredible job. We are very proud that it's so accurate and so nice. So, and then something about the installation. We built the bridges on a big barge to Copenhagen with, and we use a big shear leg, lifting in position, and then the moment comes that you open and close the bridge and hope that everything is working and it still functions, and it is. And it was really for us. We were a bit nervous because you have a series of hydraulic systems and a series of electrical systems that all should need work together to make it working. And up to now, we are lucky that it works perfectly and we have no interruptions on the electrical side or the hydraulic side. So this is the end of my presentation. If you have time, go to Copenhagen. It's a nice city and you can visit the bridge. Thank you very much.
Explanation of a lot of engineering for a little bit of nothing floating still in the waters. Very beautiful. Thank you very much.
Your microphone is not open.
Now it's open. Please take your trophy. That was the cycle and pedestrian bridge. And last but not least, we come to the real big one, the road and railway bridges. The winner of the European Steel Bridge Award 2021 is Çanakkale Suspension Bridge over the Dardanelles. I asked Jenna for some praising words.
Indeed, I'm president of ECCS this year, but really it's proud. I'm proud of these awards because in Turkey, for years, I mean, you listened to the general director before. I mean, many bridges have been constructed. However, first 4 bridges have been done by different countries with the participation of Turkish engineers and architects. However, this one mostly have been done by Turkish engineers and architects. However, naturally, I mean, COVID supported this project, I mean, as designer of the project. However, Turkey proved that Turkey is able to construct this size of project everywhere in the world. That's why I'm proud of this awards project. Now, I would like to invite all partners, I mean shareholders of this project to the stage.
These are for the owner, the General Directorate Highways, for the representatives. Yes, please come over here. For the architect, the main architect, please keep the music down, thanks. The main architect is Chalk. Somebody here, please, come, welcome. The engineer is Tony, already mentioned. Yes, please. The general contractors, DL, E&C, EMAG, SP Ecoplant, and Yapi Makazi, and for the steelwork, Chimkash. manage this big team. Very much. Congratulations, all of you. Can you get over there? Yes.
Yes. I would like to give this one first. Highway General Directorate on behalf of the victims. But I have to explain that. I mean, there are some more trophies that we will give up later. To say something. But first of all, but before, I mean, maybe a couple of
Birkaç kelime söylemek ister misiniz?
Öncelikle sempozyumu düzenleyenlere ve bütün katılan herkese ben çok teşekkür ederim.
First of all, I would like to thank those contributors of this symposium and who is making this symposium.
Sabah ben konuşma hakkımı çokça kullandığım için çok uzatmayacağım, merak etmeyin.
Morning time I speak a lot, so I will speak more.
Bizim için çok motive edici bir ödül bu.
It's a great motivation for all of us.
Biraz önce Yener Bey aynı şeyleri söyledi ama ben tekrar edeceğim. Tabii bundan önce 4 tane asma köprü yaptık biz Türkiye'de ama ilk kez Koreli ortaklarımızla beraber kendi şirketlerimiz ve Türk mühendisliği bu kadar işin içerisinde oldu ve dünyanın en büyük açık asma köprüsünü kendi mühendislerimizle beraber imal ettik.
We have done 4 suspension bridges before, but first time we have used most of our engineering management together with our colleagues from foreign countries.
Bundan sonra dünyanın çeşitli yerlerinde veya Türkiye'de kendi şirketlerimizle, kendi mühendislerimizle ortaklıklarla beraber farklı, daha büyük açıklıklı asma köprüleri yapmayı ve yapacağımızı hayal ediyoruz.
We are dreaming that we would complete bigger projects, bigger span bridges with our engineers and our team, our contractors here.
Ve bundan sonraki ödülü de yine almaya biz talibiz.
And we will get to next time this award again.
Hepinize çok teşekkür ediyoruz.
Thank you very much.
Tüm ekip arkadaşlarımız adına.
On behalf of all our team, thank you very much.